Hello, this is Aaron from TwoShelf. In this video, I'm gonna show you how set up an anim sequence asset to be used with Atoms. For the first example, let's import an Atoms clip that we already processed in Maya Houdini, so it has already the Atoms data on the joints. So to import an anim clip, just go on the Atoms crowd menu and import Atoms anim clip. This will open a dialog to import an FBX or an Atoms clip. If your clip is an FBX, please don't use the standard FBX importer because it will not import the custom attribute on the joints. So use these commands. So let's go to my Atoms crowd and my data directory. I have all the. Let's go to the clips, and my main work is this one. So let's open. I want to import in Atoms content, and let's select the skeleton, and it's here. So let's open the clip. As you can see, since there are already some Atoms attribute on some joints, the plugin already imports a curve here in the anim sequence asset. You can show the curve here, and it's also create the Atoms anim clip user asset data that use it to specify the attribute for this clip. So first things we need a name. So let's call man walk. This one is the blend frame after foot up, so it's used to recover from the foot down position with the foot lock on to the current position of the foot in a clip. So 2 frame or 3 frame should be enough. Loop start. So let's have a look to my clip. Let's bring, for example, this as a start, and this one go until something like here, probably 70, yeah, like 36, 70. Let's use, I don't know, 3 frame for blend. I need the loop on because it's a looping clip. I can leave the foot lock on. I need to specify direction for this clip. This clip is moving the y-axis, so this one is fine. If you have more choice here, if you have already some direction metadata inside the clip, you just can use the clip mode, or you want to use the pelvis, or the difference between 2 joints, especially for quadrupeds. This option is the best one. So now the transition frame. So the transition frame is used by the state machine to change from one clip to another if the state is changing inside the agents without waiting for the end frame. So you can put in between frames between these two value to tell the state machine that can change the state and play another clip. You can put manually here multiple frame value, or you can compute automatically with this tool here. Let's put a reference frame that in my case is the 37, and this one is the threshold on the difference. 0.5 should be fine. Compute, remember to close it to see the difference, and you can see it's fine, it's correct. So 70, so 70, so it's fine. This other option is to compute the pelvis states that Atoms is used to adapt the agent to the terrain. In this case, I have already the pelvis state attribute on the hips and the foot joints, so I don't need it. But if you need to recompute, you can turn on and set. This one is a Z value for the ground position. Instead the clip velocity offset, apply a velocity on your root. This one is useful if your clip has no root motion, but it's an in-place clip. In this way you can add some motion on the clip, and this is important because atoms need a proper root motion on the input clip. And then let's set the managing type, and if you want you can edit the foot down data. The foot down data is used to apply the foot lock during the simulation. So let's say it for kernel, for example, let's show this one. So this curve is the foot down for the left foot. So basically during the simulation, if this value go to 1, atoms apply a foot lock on the feet, and then when you go to 0 it releases the feet from that position. In this case, as you can see, there are some wrong value here. You can edit manually if you want, or you can use the compute atoms foot down data. You can use either the velocity, so here you put a velocity threshold, or you can use the ground dates. So let's look with 0.5, and see it's changed. Let's see, it's fine. Yeah, seems fine. So in this way you can add. If you want to add this curve manually, the syntax here for every metadata is the name of your joint, then at. This one is the metadata type ID. If you don't want to use the metadata type ID, you can use the string int, bool, double, vector 3, and so on to specify the metadata type, and this one is the metadata name. So my clip is ready. Let's have a look if it works. So let's save this one. We'll create an agent group. Let's create a grid layout. Select my managing type, and then let's add a clip reader. Set our clip. Let's add a couple more agents. Display. And seeing that it's working fine. Delete the agent group. Now let's have a look how to set up an anime sequence that has no root motion. For example, let's go in the anime starter pack with my mannequin. Let's open the clip. Okay, let's add the AtomsUnreal clip user data. Okay, set a name. It's a frame for the cover, the footlock is fine, 0. Let's use the transition frame to compute the loop ends. First thing we need to set the agent type. Okay, and now compute atoms transition frame. My 0, let's put 0.5 as threshold. Compute. Let's have a look. So 13 and 27. 13 is close, but is the wrong fits on the ground, so it's not fine. This one is not good. 27 probably is the right one. Let's have a look here. Yeah, it's similar, so we can use a sand loop, and probably then we don't need the 14. Okay, let's put reframe of blue of lens. Turn on the loop. direction static is fine since it's moving just one direction. On the y-axis, so this one's correct. Transition frame stop. I need the ground 8 data, so I need to let Atoms compute turn on, and my ground is at 0, so this one is fine. Leave it 0 here, and now the clip velocity offset. Since this animation is in place, we need to add some root motion to this clip, because atoms need a proper root motion. And because if I use this clip like this, let I show you what happened. Put a grid layout, making, and clip reader, where is clip reader? I walk, so if I press play, you see I have just in place animation. So the agent stay there, doesn't move. I need some movement there. So let's go here and add velocity offset. That in this case on the y-axis, let's try, I don't know, 6 or 5. Let's save, let's play, and seems much better. Thank you for watching, and see you in the next video.